Hi all. Today we are going to see a problem based on Bode plot. So here is the problem. To sketch a Bode plot for the following transfer function and determine the system gain k at a given crossover frequency to be 5 radian per second. So what is the transfer function? G of is equal to k s square by 1 plus 0.2 s into 1 plus 0.02 s. So first step is to replace s by j omega. G of j omega equal to k into j omega square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. For instance, let k equal to 1. So g of j omega equal to g of j omega square divided by 1 plus j of 02 omega into 1 plus j 0.02 omega. So first we will be finding the magnitude plot. To find the magnitude plot, we need to have two frequencies, omega c1 and omega c2, and this is called as corner frequencies. To find the corner frequency, we will be dividing 1 divided by the pole. So here the pole is 0.2 and 0.02. So omega c1 equal to 1 by 0.2, it is 5 rate per second, and omega c2 equal to 1 by 0.02, it is 50 rate per second. So then we are going to put a tabular column stating the term, corner frequency, slope, and change in slope. So the term will be g of j omega square. So the corner frequency for the slope, which is in the numerator, is plus 40, and the next one is 1 plus g 0.2 omega. It is in the denominator. So whenever it is in the denominator, the slope will be minus 20. So the corner frequency, as we found already, is 5. So the change in slope would be 40 minus 20 equal to 20. So the next pole is 1 by 1 plus j 0.02 omega. Omega c2 equal to 1 by 0.02. It is 50. So the slope is minus 20. So 20 minus 20 becomes 0. So this is the magnitude plot. Apart from the corner frequency, we should have two frequency other than that, omega L and omega H. The omega L value should be less than omega C1 and omega H value should be greater than omega C2. For instance, let us take omega L to be 0.5 rate per second and omega H is 100 rate per second. So then we are going to find A. So A is equal to G of j omega in dB. So at omega equal to omega L, A is 20 log of j omega square. So 20 log 0.5 square is minus 12 dB. So the same case we will be putting for omega equal to omega c1, omega c2 and omega h. Omega L and omega c1 will have the same formula and same calculations. While omega c2 becomes A equal to slope from omega c1 to c2 into log of omega c2 by omega c1 plus A at omega c1. So it becomes 20, the slope from omega c1 to omega c2 into log of omega c2 is 50 and omega c1 is 5. So 50 by 5 plus 28. So this becomes 48 dB. At omega equal to omega h, A equal to slope of omega c2 into omega h into log of omega h by omega c2 plus A at omega equal to omega c2, the previous one. So the omega h becomes 48. So now we have the points omega and A value. 0.5 minus 12 dB, 5, 28 dB, 50, 48 dB, and 100 and 48 dB. So this is the first graph we are going to plot in the Bode plot. After magnitude plot is done, we are going to do the phase plot now. So phi equal to g of angle of g of j omega. This angle of g of j omega is 180 degree minus tan inverse of 0.2 omega minus tan inverse of 0.02 omega. So here we have another tabular column stating as omega tan inverse of 0.2 omega tan inverse of 0.02 omega. This is to simplify. So phi becomes angle g of j omega degree in degrees. So we take the omega values here as 0.5, 1, 5, 10, 50 and 100. By substituting the specific values of omega, we get the phi value. So this becomes another graph. So we are going to plot this omega and the phi values in the graph sheet. So as we have plotted in the following graph, the scale is y-axis is 1 unit 10 dB and y-axis is 1 unit 20 degree. The 10 dB is for the magnitude plot and 20 degree is for the phase plot. So we have plotted the values as A, B and C and D for the magnitude plot and E, G, H, I, J as in the phase plot. So these are the points which have already plotted and we have also included the slopes of the plots here in the graph as well. So here comes the main question. What is the system gain K at omega equal to 5 radian per second? As per the graph, as you can clearly see, at a 5 radian per second, A is 28 dB. So if the gain frequency is 5, then the frequency of the dB gain should be 0. So every magnitude plot should be added by minus 28 dB. So 20 log k equal to minus 28. So k value is gives us 0.0398. So we are going to plot a graph such that so the degrees are dBs are minused by minus 28. So omega and a dash becomes 0.5, 5, 50, 100. So all the values comes here as minus 38, 0, 20 and 20. So now we can plot the graph. So for k is equal to 0.0398, we have plotted the graph as a dash, b dash, c dash and d dash so that we can specifically know the difference between the two magnitude plots. So this is the Bode plot explanation of this problem. Thank you.